In section 2.4, we're going to be learning more about linear equations. And in this section, we're going to focus on writing the equation of a line when we're given its slope and a point on the line, or other various pieces of it. Let's start by looking at some important forms of linear equations. Now, we have already discussed the first type that we have listed here, the slope-intercept form, y equals mx plus b. Another common form that you will see is what we call point-slope form. In point-slope form, it looks like the equation y minus y1 equals mx minus x1, where m is going to be your slope and x1, y1 is going to be some ordered pair or some point, and that's why it's called point slope. Then the third form that we talk about is called standard form. And in standard form, you have the form of ax plus by equals c. You want a and b to be integers, and we would like for a to be greater than 0. So when you're writing in standard form, that's some rules you want to try to follow to get the equation to that form. We're going to look at a couple examples now. We're trying to write the equation of our line when we're given a point and a slope, and then we're going to look at what if they just give me 2 points. So let's use our point-slope form for this equation. We have the point and we have the slope. So let's take y minus y1. So again, my point is my x1 and my y1. So that would be minus 5 equals m, which would be 2/3 times x minus my x1, which is -3. But minus -3 would be +3. Now, if we keep our formula or our equation in point-slope form, that would be our final answer. Now, one of the things that we'll look at later is being able to take that form and switch it to the other two forms. What if I want it in slope-intercept form, or what if I want it in standard form? For right now, we're going to go ahead and keep it in point-slope form. Our next example, we are given 2 points. Well, when you write the equation of a line, you always need to know at least a point and a slope. Since they don't provide the slope, I'm going to have to calculate it. So let's subtract our y's. So I'll do 5 minus -7 over our x's, 3 minus 5. But 5 minus -7 will be 12, because that's the same thing as 5 plus 7. And 3 minus 5 is -2, so I now know my slope is -6. Now I can go to point-slope form, which says we take y minus y1. Now in this case, it doesn't matter which equation or which ordered pair that I use, so I'm going to use this one first. So I'd have y minus 5 equals m, which would be -6, and then x minus my x1, which would be 3. Now, because it doesn't matter which of those 2 points I use, there is an alternate form of this, and I could use y minus my y point in the second ordered pair would be -7, so minus -7 will be the same thing as +7, equals -6, and then x minus 5. You need to understand that both of these forms, or both of these equations, are equivalent. It's hard to see that when they're written in point-slope form, but when we start translating to other forms, you would be able to see that those two equations are the same. Now let's practice changing between all the different forms. So we want to write the equation passing through 4, -2 with a slope of -1/2. So let's first of all do it in point-slope form. So it would be y minus my y value, which would be minus -2, so we'll make that +2, equals m, well my slope is -1/2, and then x minus my x value, which would be 4. So we can leave the answer like that in point-slope form. Now, in the next part of this problem, we'll just change that over to slope-intercept form. So if we take that equation, and let's go ahead and distribute my -1/2 through my parentheses. Well, that gives me -1/2 plus 2. But remember, slope-intercept form is y equals mx plus b. So I want to get that y by itself, so we're going to subtract a 2 from both sides. And when I do that, I get y equals -1/2 x. Then the last thing is I want to change that to general form. So taking what I have now in slope-intercept form, remember that I said that we want to get ax plus by equal to c, and we want a and b to be integers. Well, right now we have a fraction in this. So what we're going to do is we're going to multiply that entire equation by 2 to get rid of the 1/2. So that's going to give me 2y equals negative x, because negative 1/2 times 2 would be negative 1x. But we need to also get our x and our y together. So let's add an x to both sides. And when I do that, I have x plus 2y equals 0, and that would be my general form. So all three of these equations are equivalent, but they look entirely different based upon the form that you're writing them in. Now we're going to look at graphing some equations using our intercepts. We'd previously graphed using slope-intercept form, but there is a quicker way to graph, especially when you're in standard form or general form, and that is to use the intercepts. Now, if you recall, we talked about to find the intercepts, if you want to find the x-intercept, you want to let your y equal 0. So if I take this equation and put 0 in for y, notice that I get 3x is equal to 15, which means x is 5. So what that tells me is that I am touching the x-axis at 5. So we're going to have a dot right there at the point 5, 0. Now to find my y-intercept, we let x be 0. So if I take my equation and put 3 times 0 plus 5y equals 15, we get that 5y equals 15, or that y equals 3. So I now know I'm touching the y-axis at 3, which would be the ordered pair 0, 3. And now that I have those 2 points form a line, so I could just draw the line between those, and that would be the graph of my line, 3x plus 5y equals 15. And notice that I didn't have to put it in slope-intercept form to sketch. Now let's take a moment and apply what we've done so far to a word problem. So you have an office manager who has ordered 140 packs of printer paper, and based on the average daily use, she knows that the paper is only going to last about 80 days. So we want to find an equation of the line that would model this situation and put it in standard form. So let's first of all start by writing some ordered pairs. So if we start with the ordered pair 0, 140, representing at t equals 0 when time 0, or at the very beginning of when she ordered 140 packages of paper. Then 80 days later, so x is going to be the number of days that have passed. 80 days later, we know that she's going to be out of paper, which would put her at 0. So x is paper, or x is days, and y is going to be the amount of paper she has. Well, we now can use that to find my slope. So subtracting my y's would give me 140 minus 0 over subtracting my x's would give me 0 minus 80. Well, that's going to be negative 140 over 80, but those are both divisible by 20, so that gives me negative 7/4. So that's going to be my slope. Now, to put that in standard form, we really need to start with one of our other forms and then rewrite our answer into standard form. So let's use point slope form. Y minus, and let's use the ordered pair 0, 140. So y minus 140 would equal m, which is negative 7/4, x minus my x point, which is 0. But now, if I distribute, I get negative 7/4 x. But in standard form, remember, we don't want the fractions. We want our a and our b to be integers, so we're going to multiply this entire equation by 4. Well, that would give me 4y minus 560 would equal negative 7x. And let's get our y over with our x. So we'll subtract a 4y. And that gives us that negative 560 equals negative 7x minus 4y. But also remember we said we wanted our a to be positive, and right now it's negative. So we're going to divide everything by a negative 1. And if I do that, I'm going to get 7x minus 4y is going to equal a positive, or that'd be plus 4y, because we divide the negative 4 also by a negative 1. So it'll be 7x plus 4y equals 560. So there's our equation in standard form. Now let's use what we have to figure out how much should she expect to have at the end of 30 days. Well, let's go back to our point slope formula of y minus 140 equals negative 7/4 x. And x, remember, was our number of days. So let's put 30 in for that. But if we multiply negative 7/4 times 30, remember that we can simplify by taking a 2, think of that 30 as being over 1. 2 would go into 4, 2, and 2 would go into 30, 15. And now I can multiply across the top, and we would get 7 times 15 would be negative 105 over 2. So we have y minus 140 equals negative 105 over 2. But we want to get y by itself, so we'll add 140 to both sides. So those are going to cancel. We're going to get y equals negative 105 over 2 plus 140 over 1. But that would be common denominator of 280 over 2. But negative 105 and positive 280 is going to give me 175 over 2. And now if I divide that out, I'm going to get 87.5. So at the end of that time, after 30 days, she can expect to have 87.5 packages of paper.